Hi guys, this video will help you out with our homework assigned Monday, which is introducing or an introduction to complex numbers. The assignment is to do numbers 1, 2, 3, and 11 through 20 on the back side, so the second page, the page opposite that we started in class last week, or last Monday, okay? So what we're going to do is we're going to talk through a couple of these, and hopefully after talking through a couple, the rest will make sense to you. We're going to start with number 2. What you're given is I to the 210th power, and you're asked to simplify, okay? So just to recap something that we did in class is we figured out that I is simply the square root of -1. I squared would be I times I, which is -1. I to the third power would be I squared times I, which is nothing more than negative I. Okay? I to the fourth would be I times I, which is -1, times another I squared, which is also -1, so -1 times -1 is +1. And we also looked at some cases in class where, like I to the 5th, I to the 6th, and what we found was that this process, this pattern, just repeats itself over and over again. So I to the 5th is the same thing as I to the 6th is the same thing as I squared, I to the 7th, I to the 8th, I to the 9th, and you get the idea, okay? So we need to figure out what this is equal to, and I can tell you for sure it's going to be equal to one of these. We just have to figure out which one. Well, if we think about it really carefully, the pattern is by 4s, right? We're just repeating the same 4 process. So if we figure out, if we take 210 and divide it by 4, then we'll get an idea as to where we are in this 4-step process. So 210 divided by 4 is not a whole number. It works itself out to be like 52 point something. So what I'm going to do is we know that 52, if we just chop that number, chop off the rest of that remainder and multiply it by 4, we get 208. So that means that I to the 208th puts us at 1 again, because it's an even divisible of 4. Okay, so I'm going to actually write this down. I to the 208th. Okay, that's an even number divisible by 4. So that means that I to the 209th would put us back up here. And that would mean that I to the 210th would be equal to the exact same thing as I squared, which is equal to -1. Okay? So I to the 210th is equal to -1. That wasn't too bad. Okay. Let's now work through another one. Let's work through one in the other section. Let's do number 17. Okay. So in number 17, what are you given? You're given, dandy, worksheet 3x root -75a. Okay. So this is what you're given right here, and we're asked to simplify this. So what I'm going to do is I'm going to start with a very, very basic step of just splitting -75a into 3 factors. So we have -1, we have +75, and we have a, all of which are their own square roots. Okay, you see what I did? Why did I choose -1 as one of the factors? Well, we know what -1, the square root of -1 is. It's simply I. So with that -1, I'm going to simply, or with that square root of -1, I'm simply going to change it to I. Okay? 75, root 75, we can split into further factors where we need at least one of them to be a perfect square. So let's think about the factors of 75. We have 3 and 25. So root 25 times root 3, and we can't forget about our root a at the end. Okay? So this is what you have. 3x We have I, which came from the square root of -1. We have the square root of 25, and the square root of 3, which came from the square root of 75. And we have root A, he's just along for the ride. So can we take any of these further? Well, we know that the square root of 25 is simply 5. So we have 3x times I times 5 times root 3 times root A. Okay? So this whole mess we can clean up a little bit. We know that 3x times 5 is 15x. So we have 15xi, okay? And then we have root 3 and root a, which can be put under the same radical. And that works. So that would be root 3a. So I think that's as far as we can go. 15xi root 3a. Okay? Good luck with this assignment. Let me know if you have any questions. Feel free to email me, and I'll see you guys in class on tomorrow, Tuesday, or Wednesday. See you then.